Hey guys, how are you today? It's pre-calculus time, and are you excited for our next lesson? We're going to discuss today all about a parabola. Now, what are our learning competencies? We are going to define a parabola, determine the standard form of the equation of a parabola, and of course, we are going to graph a parabola in a rectangular coordinate system. Let's proceed with the very first competency, and that is, we're going to define a parabola. What is a parabola? Parabola is said to be a set of all points such that its distances from the fixed point and from the fixed line are the same. Now, what do you call this fixed point? This fixed point is called your focus. On the other hand, the fixed line is called now your directrix. Take a look now on the diagram. You notice there, F is represented by focus and your K is represented by directrix. So they are said to be constant or the same. Okay? Now, let's take a look on this diagram. Another terms would be discussed today. The first one there, as you observe, we have the axis of symmetry. Now, what is this all about? Axis of symmetry. It is said to be the line through the focus, perpendicular to the directrix. It divides the parabola into two parts, which are the mirror images of each other. So if you take a look on the line which is said to be in the purple color, that is now your axis of symmetry. Okay. On the other hand, we have here another term which is the vertex. Okay, the vertex is said to be the turning point of the parabola, which is located midway of the focus and of the directrix. Okay, so there you have the vertex. And of course, another term here is your latus rectum, the one in peach color. When you see latus rectum, this is a chord through a focus parallel to the directrix. FYI, latus rectum is a compound of the Latin word meaning side and rectum meaning straight. So again, if we combine latus and rectum, it's a side straight or straight side. Okay? So there you have the different terms. And the same true when we consider the second competency that is now on the equation of a parabola. Now, let's discuss first the first form, which is the standard form. And we have two forms here, which is vertex at origin. If you take a look on our table, okay, so you notice there that once our parabola opens to the right or to the left, okay, your equation, take a look here, your equation on the variable y is said to be in the second degree. Okay, take note, when we consider parabola, only one variable is on the second degree. So if the variable y is on the second degree, therefore its opening is either opens to the right or to the left. And of course, its axis of symmetry is along the x-axis. On the other hand, okay, if the parabola opens upward or downward, okay, your equation, take note, your equation or your variable x is on the second degree, okay, and the axis of symmetry is said to be along the y-axis, okay. And of course, there are some terms there. We have the 4p, okay. Later on, you would observe that 4p is said to be necessary for us to consider the graph and the equation of this parabola. Okay, 4p again is represented by your length of your latus rectum. Okay, let's take some examples here. If we recall the vertex at origin, okay, if the parabola opens to the right with vertex at the origin, what will be the equation? Okay, opens to the right. Yes, you're right. The answer is letter D. Why? Again, it opens to the right because variable, okay, is said to be your variable is on the second degree. And if it's right, your opens to the right, you would observe that your 4p is always positive. On the other hand, if your 4p is negative, meaning it opens to the left. Okay, let's try another one. Which of the parabola equation of a parabola is said to be downward if the vertex is at the origin? What will be its equation? Okay, this time opens downward. Yes, the answer there is letter B. Why? Because if it's downward, okay, your variable x is on the second degree, and of course, your 4p is said to be negative. If your 4p is positive, and it's the variable x is on the second degree, therefore it opens upward. Okay, let's take on the second form of your parabola, which is vertex at HK. Okay, this time the only difference, the first form we have discussed on the standard form is that vertex at origin, this time HK. So again, the same concept. If the opening is to the right or to the left, your variable y is on the second degree and the axis of symmetry is parallel to your x-axis. Okay, and if its opening is upward or downward, your variable x is on the second degree and the axis of symmetry is again parallel to y-axis. Okay, and of course, considering your 4p sign, positive, either right or upward, negative 4p, it's either left or downward. Okay, let's take an example here. Okay, recall, if a parabola opens upward with vertex at HK, so what will be now your equation? Yes, the correct answer is letter A. Why? If it's upward, again, x is on the second degree, and your 4p should always be positive. Again, let's proceed with the next. How about if it opens to the left and vertex at HK? Okay, the correct answer there is letter D. Yes, again, if it opens to the left, your variable y is on the second degree and your 4p is negative. So that is all about on the equation of a parabola. As we proceed, we're going to come up now with the second form of your equation. We are through with the standard form. Let's proceed with the general form of the equation of a parabola. So it says here, exactly one of the variables, either x or y, is said to be on the second degree. So notice here, ax squared plus cx plus dy plus e equals 0. That is with respect to x. And then on the other hand, by squared plus cx plus dy plus e equals 0. Okay, so if you notice there on our first general form, x is on the second degree, so it's either upward or downward. And then of course the second equation, y is on the second degree, it's either opens to the right or opens to the left. Okay, let's take this converting standard form to general form. So let's try this first equation. We have quantity x minus 3 squared equals negative 8, quantity y plus 1. So this standard form is to be transformed or written in its general form. So what will we do? Okay, we're going here to apply what? We're going to expand your square of binomial, and then of course on the other side, we're going to apply distributive property. So I guess you know already how to expand a binomial. So the expand of your binomial there is x squared minus 6x plus 9. Okay, and then of course once we apply distributive property on negative 8, okay, distribute negative 8 times y, negative 8y minus 8, negative 8 times 1, it's negative 8. Okay, and of course we're going to transform this one to general form. So therefore, if it's general form, it is always equated to 0. So we're going to what? Transpose negative 8y and negative 8 on the other side. So there you have. And of course, once we apply transposition, they have changed their signs and equated to 0. And then after that, we are going to combine like terms. Okay, what are our like terms here? Simply your constants. And we're going to arrange in the general form. So therefore, we have the x squared minus 6x plus 8y. How did we arrive with 17? 9 plus 8 is equals to 17, and of course equated to 0. So that is how to convert standard form to general form. Again, we apply expansion of binomial, okay, and of course distributive property. Now let's proceed with this time from general form to standard form. Okay, with this example, y squared plus 8y minus 16x minus 48 equals 0. Okay, so how do we convert general form to standard form? Okay, so you notice here that only one variable is on the second degree. So we would those variable and the terms with the same or said to be on the second degree will stay on the other side, and of course your remaining variable together with the constant should be written on the other side. So meaning on this example, y is on the second degree, so therefore y squared and 8y should remain on that side, and then 16x and 48 would be written on the other side, considering the sign. Okay, so there you have. Now you notice there we have a blank. So the same true or concept we have applied on the previous conic, and that is we need to apply completing the square. Okay, so when we complete the square, applying your middle term, the numerical coefficient of y there is 8. So 8 divided by 2 is equals to 4. Square it, it's 16. Okay, this 16 now is to be written on the blank on this side and of course on the other side. Okay, so we're going to write 16 there and another 16 on the other side to make it balance. Okay, now after we have applied completing the square, we know that that is already a perfect square trinomial. Y squared plus 8y plus 16 is already a perfect square trinomial, so we could now factor it out, and the factor of that is okay, y plus 4 quantity square. The same true on the other side. Okay, we could simplify it further by, of course, combining like terms, and that is with respect to constant. So 16x plus 64, how did we arrive with 64? 48 plus 16 is equals to 64. And of course, the next step, you notice here on this side, okay, 16x and 64, we are going to extract the numerical coefficient of your variable. With respect to x is 16, so we're going to extract 16. So therefore, we have 16 quantity x plus 4. So this is now our, okay, from general form of the equation of a parabola to the standard form, which is quantity y plus 4 squared equals 16 quantity x plus 4. Okay, so again, when we convert general form to standard form, we apply completing the square. Okay, then of course with that completing the square, it's now a perfect square trinomial, and of course we're going to extract the numerical coefficient of your variable on the other side. Okay, let's proceed. This time we are through with the definition, we are through with the equation, and again for the final discussion we are going to graph a parabola. Now how do we graph a parabola? So the same with the other conic we have discussed. Okay, specifically for circle, we consider the coordinates of your center and the length of your radius. For a parabola, for us to graph, okay, we need to consider first your vertex and of course the length of your latus rectum, or simply the value of your p. So as we have here the first example, y squared equals 8 quantity x minus 3. So you notice it's a combination of vertex at origin with respect to y and of course vertex at hk with respect to x. Okay, so let's identify its vertex. Now the vertex there is what? 3, 0. Why 3, 0? With respect to x, you notice here, okay, x minus 3, equate that to 0, then negative 3 transpose on the other side, it becomes what? 3. And why is it 0 here with respect to y? Because it is said to be on what? Vertex at origin. So therefore, your vertex here is 3, 0. Afterwards, we would identify, on our previous discussion a while ago, your value of your 4p. Okay, so our 4p here is what? 8. There you have. 4p is 8. Now again, what's the significance of this 4p in our graph? I said a while ago that your 4p stands for the length of your latus rectum, to make it as a mirror or said to be symmetric. Okay, now so 8 units. The latus rectum has a length of 8 units. Okay, and how do you make it asymmetric? Of course, that is you're going to divide both sides by 2, and that is 4 units, both either left or right, or upward or downward. And of course, consider the value of your p. Okay, we are to solve for the value of your p. So how do you do that? divide both sides by 4. Okay, so divide both sides by 4. And of course, the value of your p here is either positive or negative 2. And what is the significance again of p? Your p here would signify now the distance from your vertex to your focus, and then from your vertex to your directrix. That's why we have positive or negative, because they are said to be opposite directions. Okay, so we are now ready to graph a parabola. Okay, so using our Cartesian coordinate system here, let's plot first our vertex. So our vertex is at 3, 0. So meaning 3 units to the right, 1, 2, 3. And we're not going to move either upward or downward. So this one. And of course, do not forget to label. And that is, we have 3, 0. Afterwards, after considering now your vertex, okay, we have here your value of your p, which is positive or negative 2. Now, the question here is, what is the opening of your parabola? Okay, you notice that your variable y is on the second degree, so therefore it opens what? And of course, your 4p is positive. So it opens to the right. Yes, you're correct. Okay, so from here, from your vertex, 2 units to the right. So therefore, 1, 2. Okay, that is 5, 0. That is now your focus. Okay, and from your focus, from our definition a while ago of your latus rectum, okay, that it is said to be parallel to your directrix. Okay, now your 4p here is 8. A while ago, I have told you that 4p now is the opening or the length of your parabola with respect to the opening. Okay, so how do you make it a symmetric if it's 8? So meaning, from your focus, 4 units upward and 4 units downward. So from here, again, how did you arrive with 4 units downward and 4 units upward? Because the value is 8. And to make it symmetric, divide it by 2. Okay? So from your focus, 1, 2, 3, 4, 4 units downward. So our length of your latus rectum here is 5, negative 4. Okay? And of course, on the other hand, 1, 2, 3, 4 upward, and we have your length of your ends of latus rectum is 5, 4. Okay, so again, if you are let's say you have your question with respect to this one, how did we arrive with that LR? Again, this refers to your 4p, which is 8 units, and to make it symmetric, okay, that is now we have divided into 2 equal parts. Okay, so we are ready to connect your parabola, okay, by making a curve. So there you have. And of course, we do not done yet or through yet, because we are to consider, of course, your directrix. A while ago, it's positive 2 vertex. It's positive because you're going at 2 units to the right, and this time it's negative 2. Why? Because from the vertex, 2 units to the left. So 1, 2. Okay, now why is it line? Because a directrix is said to be a fixed line. Okay? And the equation of your directrix is equals to 1. So x is equals to 1. So again, before we proceed to the next example, when we consider the graph of your parabola, we need to find out first the coordinates of your vertex, and of course, the length of your latus rectum, the value of your 4p, and the value of your p. Okay? So, let's proceed with the second example. Our second example here this time is in general form. Okay, so how do we graph a parabola whose equation is in general form? We simply convert that equation into a standard form. So that's our previous lesson a while ago, okay, or topic a while ago. So you notice here, it's x is on the second degree. So therefore, the variable with x, or terms with variable x, should stay on this side, and of course y and the constant should be written or transposed on the other side. And of course we are going to apply what? Completing the square. Okay, so I have here now our standard form. Quantity x minus 1 square equals 4, quantity y plus 2. That is now our conversion from general form to standard form. You could check that later. So we could now identify your coordinates of your vertex. Okay, what is now our vertex? This is now vertex at HK. Yes, you're right. The vertex now is 1, negative 2. How did we arrive with that? X minus 1 equate to 0. Okay, transpose negative 1 to the other side, so becomes 1. Okay, the same true with y. Y plus 2 equals 0. Transpose positive 2 on the other side, it becomes negative 2. So therefore, our vertex is 1, negative 2. Now, the next thing to consider is the value of your 4P. What is your 4P? Yes, it's 4. Okay, 4. And that means, what does this 4P means? The length of your latus rectum, 4 units. And to make it symmetric, meaning 2 units. Okay, before that, take a look on our variable x. It's on the second degree. So if it's on the second degree, it's either upward or downward. But take a look on your 4P here. It's positive 4. So therefore, its opening is upward. So meaning, to make it symmetric, 2 units to the right and 2 units to the left. So divide both sides now with 4. Okay. So therefore, our P is equals to positive, negative 1. Okay. So let's graph using a Cartesian coordinate system with our vertex, 1, negative 2. So 1 unit to the right and 2 units downward. Okay, there you have. Then, do not forget to label. And after that, from the vertex, okay, this is, a while ago, our question is this, where does this parabola opens? And it opens, what? Upward. So that means positive 1 from our vertex, 1 unit upward. There you have our focus. And the coordinate is 1, negative 1. Okay? From here, we consider the length of your LR or latus rectum, and that is 4 units. So meaning 2 units to the right and 2 units to the left. So 1, 2, there you have. Your ends of your LR is 3, negative 1, and on the other side, we have 1, 2. Okay, there you have. The coordinates of that is negative 1, negative 1. Okay, so we are now ready to connect. So there you have. So again, with respect to your LR, length of your latus rectum, your 4P is 4. Then we divide it into 2 parts to make it symmetric. Okay? And of course, the last step is considering your directrix. So from the vertex, 1 unit to 1 unit downward. So from your vertex, 1 unit downward, there you have. And the equation of that is y equals negative 3. So why is it y equals negative 3? You take a look on the our y-axis. So 1, negative 1, negative 2, negative 3. So it's negative 3. Okay? So again, from graphing a parabola, considering our vertex, coordinates of your vertex, and the value of your 4P, which is the length of your latus rectum, and of course, your value of your P, which is the distance from the vertex to your focus and vertex to your directrix. Okay, so we could now sum up or generalize our lesson. Today we have discussed all about a parabola. That when we say parabola, this is said to be set of all points such that its distances from the fixed point, which is called your focus, and from the fixed line, which is called now your directrix, are said to be the same. We have also discussed equations of a parabola, that we have 2 forms also. We have the standard form, vertex at origin, vertex at HK. And of course, we have the general equation, which is always equated to 0. And take note that only one variable is on the second degree. It's either on x, variable x, or variable y. If your variable x is on the second degree, it is either opens upward or downward, depending on your value or the sign of your 4P. And on the other hand, if your y is on the second degree, it opens what? Either to the right or to the left. Again, depending on the sign of your 4P. And of course, last one here is we have discussed how to graph a parabola. Now, when you graph a parabola, we consider the coordinates of your vertex, your 4P, and of course, your value of your P. Your P here is, of course, the distance from your vertex to your focus, and vertex to your directrix. Okay. And of course, we are through with our discussion for today. So thank you for listening. And always remember, handang isip, handang bukas, tara na, ML na tayo. Okay? So hoping you have learned something today. Thank you again, and God bless us. See you again on our next lesson.